Hello and welcome. If you've been here before, welcome back. If you're new here, my name is Joe, and I rant about the things that I think we need to do to prepare for the coming effects of climate change. In this video, this will be the first of a multi-part series in how to build the houses of the future. So the homes of the future need to be able to withstand the coming effects of climate change. That means they need to be more durable. They need to be able to withstand harsher weather conditions. More extreme weather in more places more often is what's in the forecast. So the way homes are built today, they're not made to withstand what's coming. We also need to build houses that are made from recycled materials. A lot of materials that we use today are just because we've been using them all along. There's a whole industry set up, like the whole forestry industry, the lumber industry, I should say, is built around home construction. So that needs to change. We also need houses that can be off-grid. Climate change is going to threaten our utility systems. So look what happened in Texas this past winter. When you have more extreme weather, you're going to have more trees down, more branches down, more wires down. So let's get rid of the wires. Houses also need to be a lot more affordable relative to the prices they are at today. That's a different topic though, that's more of an economic thing. So those first three will be what I focus on in this little mini series. I think it'll be a three-part series. Our homes need to be more durable, off-grid, and made from recycled materials. Now to start off with, this first video will be how do we make houses today? I can't explain how I think houses should be built in the future without first showing you how we currently make them. And also then point out, well, what's wrong with how we currently make them? So let's jump in and look at the components of a home today. So the components of a house consist of the structure of the house. This is probably what you're thinking of in terms of home construction, but there's more to it than that. There is what are called the mechanicals. This will be your heating system, cooling system, ventilation, appliances, electrical, plumbing, all the things that make a house more than just walls and a roof. There's the environment. This is what we're trying to control to make the inside of the house comfortable for the occupants and safe as well. And then the occupants themselves make up the fourth component of a home. How many people live there, how they actually use the electricity and water, whether they conserve, whether they're wasteful, what appliances they use or don't use. These all factor into how all the systems that comprise a house all work together. I'm really going to focus on these, mainly the structure and mechanicals. I'll get into the environment more in the second part when I get into the problem with how we currently build our houses. So let's first just say we have an open plot of land here, and notice the way it's shaped. We'll come back to this in just a minute. So first, there's a foundation. Now, a foundation can be a cement slab. It can be a crawl space. In this example, I'm showing a basement. But it could be any of these three. A basement is more expensive because you have to excavate out the ground. But also certain areas you can't even you can't dig out a foundation if there's too many rocks. You might need to have a crawl space. And also with a slab, it also depends on what part of the country you're in and whether or not you're able to build that to withstand frost heaves and so forth. But anyway, in this example, I'm using a basement configuration. There's the wood frame. So these will be your 2x4s, 4x6s, 2x10s, the studs, the joists, the rafters, just the wood that makes up the skeleton of the house. Now in this example, I'm using an attic configuration where the middle part of the attic is built so someone could actually stand up there. Rafters can be built in many different ways. This is just one of many designs that a house could use. Then there is the sheathing. The sheathing is what makes up the walls. So the interior walls are going to be drywall or sheetrock. That's then plastered over to cover up the seams and the screw holes, and then painted over that. Ceiling, probably the same thing. Usually it's going to be drywall, plastered and painted over. Could be other materials as well, but Drywall is the most common type of material used for interior walls and ceilings. The exterior walls are going to be probably what's called oriented strand board, or OSB. It looks like giant pieces, giant chips of wood glued together into big sheets, because that's what it is. And then there will be a waterproofing layer put outside of that, and then the outside is probably vinyl siding, aluminum siding, could be brick, could be stone. Your flooring is going to have, there'll be a subfloor, probably also OSB or plywood, and then a finished floor on top of that, which could be carpeting, tile, a hardwood floor. And then your roof will be a couple layers of plywood that are then covered in shingles. It's typically asphalt shingles. The roofing could be made of other materials as well. There are metal roofs, other types of shingles that could be used. In this example, I'm showing what's called a ridge vent. So there's basically a line of shingles right across the peak of the roof with a little screen inside so the air can flow out from underneath. That way air from the attic can get outside, get to the outside through that vent. I'll explain more about that in just a minute. The house will have downspouts and gutters. So this is to control water as it runs off the roof. That way it's not flowing just right past your doors and windows. You can direct it off to the side, down a downspout, and then direct it away from the building. Water is the enemy of a basement. So as you can see, the way the ground is sloped, it's shown that it's sloped away from the foundation in each direction. If it's not, you definitely don't want water running towards the foundation. It will get in. So downspouts help control the flow of water off the roof. There's the insulation. Now in this example, I'm showing that pink fiberglass insulation in the inside of the exterior walls. It's typically glued to some kind of craft paper, and then might be 3 or 4 inches thick. I'm also assuming that because the attic space probably has a subfloor in the middle part anyway, so people can walk around. So there's probably insulation in the floor of the attic in that area anyway. Off to the sides, I'm showing blown-in insulation. There's really no reason for anyone to go over there. There's probably also insulation under the floor of the living space or in the ceiling of the basement, whichever way you want to look at it. We have windows and doors, of course. I mean, these are basically just holes in the wall if we're going to control the environment and keep the outside actually outside, but be able to see the outside and get in and out of the building. We need doors and windows. There are also what are called soffits, and there should be something called soffit baffles. Not all houses have these. A soffit is a vent under the roof overhang. That allows air to flow up into the attic space through that vent and then out through that ridge vent that I mentioned earlier. Now the baffles, those are put in place along the inside of the plywood that makes up the roof, so that if any of the insulation that's installed goes all the way over to that plywood, well, that would block the air from coming up through that soffit vent. So a baffle is really just, it's another vent that's put in there to prevent the insulation from blocking the airflow through the soffit. Now the house is also going to have a fuel source. In this example, I'm using natural gas. For heating, some houses could also use heating oil or kerosene. But again, in this example, I'm just going with the gas. So there's a line that would have to be dug through the yard from a service line out under the road. And then once it comes into the house, it will split off to go towards the appliances that would use the gas, whether that be the stove in the kitchen, a furnace, hot water heater, or a dryer. There's the plumbing system. Now, in this case, this isn't very accurate because there really is 4 different types of plumbing that make inside of a house. So you have the water line that comes in, whether it be from a water main out under the road, or if you have a well. And the water comes into the house and then splits, and one side of that goes over to a hot water heater, which then feeds the rest of the house along with the cold water that just came in. So I really should be showing, to be accurate with the plumbing, the cold water coming into the house, and then where it splits and goes off to the sinks and toilet and shower or tub. and also show the hot water lines separately so you can tell the hot from the cold. There will also be drain pipes, and when you flush the toilet, when you let water drain out of a sink or out of the tub or toilet or tub or shower, it has to go somewhere, and it drains back down into a pipe that goes out into the sewer line or out to a septic field. There also are vent pipes. So these would be the vertical pipes that are sticking out through the roof. This is so air can come in through those pipes. You need air to get in behind that water so that it can actually go down the drain, or at least go down quickly anyway. If you think of a can of juice or motor oil that you have to open with a can opener, you don't just puncture one side of the top of the can. You go around and you puncture the other side as well, so that is when you pour it, as fluid comes out one hole, air is going in through the other hole to backfill. So there needs to be vent pipes to do that so the plumbing can work. So again, if I was going to be accurate with the plumbing, I'd be showing the cold water and the hot water separately, the drain pipe separately, and the vent pipe separately. But just to keep things, this is going to be complicated enough once I show the entire house here. So plumbing is blue. There's also the electrical system. So there's a power line coming in from the road off of a telephone pole, comes over to the house, passes through a meter, and then continues over to the circuit panel. There's also would be a meter on the gas line. I just didn't draw it in these illustrations. But anyway, electricity gets into the circuit panel and then splits off into multiple circuits. Probably one for each room or major appliance. There could be several rooms that share a circuit. There could be a room that has multiple circuits. It really depends on the anticipated power needs throughout the house. And so once it splits off into individual circuits and goes throughout the house from the circuit panel, it then goes to outlets, switches, light fixtures in the ceiling, or other appliances that are tied into this. There's the HVAC system, or systems. In this example, I'm showing one system. It's a furnace and air conditioning unit all in one. The furnace runs off of natural gas, and then the air conditioner has a condenser outside, and a ventilation system that is sending cooled air or warmed air up into the living space through the floors. There's also going to be a return vent so that it can send air back to the furnace or air conditioner as fast as it's being sent out throughout the house. Ventilation will also include any vents or fans built into the house. So for example, if there is a vent in the kitchen for sending any smoke or anything else from the stove outside, that's shown here. And I also show a ceiling fan in the bathroom that vents up to the outside. Some people install these fans in their ceiling and then send the moisture up into the attic. They don't properly vent it up actually to the outside. You do not want to send moisture into the attic. Why is something I'll actually address in the next video. But here are your bath and kitchen vents. And there's the washer and dryer. So I'm showing a dryer that runs off of natural gas as well. And also has to vent to the outside. And then the washing machine, of course. And here you have it. Here is the complete housing system. Here's the structure and the mechanicals that all work together to control the environment. Now, of course, this is not, this doesn't show every single pipe or every single wire for this type of example, but I think you get the point. Now, when it comes to controlling the environment, at a very basic level, the structure is what is called the building envelope. The building envelope is the boundary between the outside and the inside. So outside, not only do you want to keep out the wind and the rain and the snow or the heat, you're also keeping out the animals and the bugs and the birds and the spiders and the mice, and they're all going to try to get in anyway. But basically, the building envelope is just protecting you from the outside, keeping the moisture out, keeping the wind out. We need to create something called the thermal boundary. The thermal boundary is what separates the conditioned air from the unconditioned air. Air is conditioned if you heat it or cool it. If you do something to it to make it more comfortable to the occupants, you've conditioned the air. So if you're heating up the inside, you don't want to be heating up the outside, or the attic, or the basement. This is why we use insulation. Insulation prevents the movement of or transfer of heat through conduction. That's the transfer of heat through a solid. So without insulation, if you're heating up the inside walls, you're heating up the outside walls. And if you're heating up the outside walls, you're heating up the outside air. It's very wasteful in terms of electricity or heating fuel. Same thing with the attic and basement. Those are typically unconditioned, so you're going to want to have insulation above the ceiling and below the floor to also prevent heat transfer into the attic or into the basement. There also needs to be something called a pressure boundary. Preventing the movement of heat through conduction is what insulation is for, but heat can also transfer through something called convection, or just through the air. So in order to prevent that, we need to create something called a pressure boundary. The pressure boundary just means that it's air sealed. So you want a good tight seal around the windows, the doors, but also in the walls, floors, and ceiling. If you have insulation above the ceiling, but no vapor barrier, air is still going to pass through into the attic. And it can also come up through the floor from the basement. So you want to prevent the movement of air in order to control the movement of heat through convection, but also the movement of water vapor. If water vapor can get through, then water can actually begin to deteriorate things. So a pressure boundary is a way of controlling air and water vapor. Not liquid water. Liquid water is controlled through, that's why we have shingles in the roof, that's why the ground is sloped away from the foundation. Bulk moisture, or moisture as a liquid, is controlled through the physical structure of the building. But water vapor is actually a component of air. When anyone says that air can hold moisture, that's like saying air can hold oxygen. Water vapor is just one of the types of molecules that is what air is made of. Air is made of nitrogen, oxygen, carbon dioxide, and water vapor. But what's unique about water vapor is it can fluctuate. There can be high or low amounts of water vapor relative to everything else. That depends on two things. The availability of water to evaporate in the first place, and the temperature. The warmer the air is, the more water vapor can exist. Now I'm getting off into a weather lesson, which I might do some other time. So if air can pass through, water vapor can pass through. And that is bad for materials that you're trying to prevent from deteriorating because of exposure to moisture. So for example, the drywall that's put up inside of a house, it's coated in paint, not just to make it look good, but that paint actually works as a vapor barrier, a barrier that prevents moisture from passing through into the drywall. If the drywall wasn't painted, over time it would absorb water and deteriorate. It would also allow water to pass through it and get into the framing. So we need to seal all that off to prevent that from happening. But again, that'll be something else I get into in the next video. So that's it. These are all the components of a house. This is the structure of the house, the mechanicals of the house, and I touched a bit on how the environment is controlled by all of these things. In the next video, I'll get into, well, if this is how we build a house today, and we have building codes that covers all the ways a house should be built, what's wrong with this? When it comes to climate change, there's actually already a lot of problems with this in terms of contractors that cut corners, cheaper materials that are used, mistakes that are made, homeowners that do things themselves instead of hiring a professional, and then they screw things up, and then the next homeowner has to deal with that. There's a lot of problems with how we currently build houses outside of dealing with harsher weather conditions. But especially if we're going to be thinking in terms of building houses out of recycled material, houses that are more durable, and houses that can be off-grid, the way we build houses today is not going to work. So that'll be what I cover in the next video. So thank you for watching. If you liked what you saw, please click like, share with somebody. If you have a question or something to say, feel free to comment below. And also please subscribe. And again, thank you for watching. I'll see you next time.